Audio Jungle. Audio Jungle.
Right, uniform flow, right? So uniform flow. In this already I have explained, uniform flow means the fluid velocity, okay, that fluid velocity is not changing with respect to space. It's not changing with respect to distance. It is not changing with respect to location. Then this type of flow will be called as a uniform flow. Okay. So meaning is, what is the meaning of it? In short, the meaning is very clear. In uniform flow, the velocity remains constant. Velocity remains constant with respect to space. Okay, with respect to space, velocity is what remains constant. All right. Now, this is the one. Second point is very important, that all fluid particles, all all the fluid particles, all the fluid particles moving with are moving with the same velocity. That's the mean of constant, the same velocity. How many?
Said you are not whatever.
Right. So we'll see the parallel to x-axis first. Parallel to x-axis. If you see parallel to x-axis, so parallel to x-axis means this is what parallel to x-axis. See, this is parallel to x-axis. If you see the coordinate system, this is y and this is what x. Parallel to x-axis, if resultant velocity is nothing but u. Okay, if resultant velocity is nothing but v, you can say v. So this is the resultant velocity. Okay, this is the resultant velocity. And now coming to the right, coming to the calculation of the stream function and potential function. With respect to that, we can get the velocity also for this. Right now here, if you see what is the potential function and what is the stream potential function and what is the stream function for the uh, parallel flow or uniform flow parallel to x-axis, right? So if you check here, this resultant velocity v vector is nothing but ui plus vj. Okay, ui plus vj. But if you see here, if it is parallel to x-axis, it means only one component will have, that is along x, what is that, u, and along y, what is that, v. So because we are talking about parallel to x-axis, so only u component will have, and that u component is nothing but v. Okay, because v is the resultant velocity, right? So that u component will have, and u component means along the x-axis, because it's a parallel to x-axis, so only x component will be there. And what is the x component? That is u. So what is my resultant velocity now? It's a v, that is u is equal to v, right? Now coming to the, and what about the y component, that is a small v? So small v will be 0. Why? Because in parallel to y there is no flow, because it is clearly mentioned only parallel to x-axis. So we have flow parallel to x-axis, there is no flow parallel to y, so that y component means v will be 0, right? This you need to remember. Based on this, we have to go for the calculation of the, stream function and potential function. So what to do? You know that a potential function, and we have a stream function. Okay, stream function means psi and potential function means phi. Right, anyone you can start first. So you know that u is equal to dou phi by dou x, and v is equal to dou phi by dou y, right? So you know that v component, what we have, it's 0. But what about u component? U component we have, u is nothing but dou phi by x. And what is u? U is nothing but, if you check, u is nothing but v here, because it's parallel to x-axis, so u is nothing but capital V, okay, capital V. So if you check what is the phi here, if you see, the phi value is nothing but simply, phi is nothing but Vx, right? That is the phi. Phi is nothing but Vx. Okay, once value of x is what changing, that phi value you will be getting, right? So phi is nothing but Vx. Similarly, you go for the stream function. So what is the stream function? You know that the formula u is nothing but, what is the formula for the stream function? Just opposite derivative you have to take. If you are talking about u, then it is nothing but dou psi by dou y. So, and similarly v is nothing but dou psi by dou x, right? And that also, if if you check, u is nothing but, because you are taking derivative in direction y and you will get velocity in x direction, that is, so this will be the minus sign, that you know. And you know that also parallel to y there is no velocity, so v will be 0. And parallel to x axis will have velocity, and that is nothing but capital V. That is the parallel to x axis, that is u. U is nothing but v, that already we have here understood. Okay, so u is equal to v. And what is the psi now? Psi is nothing but minus of v times y. So this is nothing but psi value, right? This is nothing but psi value, correct? So stream function and potential function we got here. Stream function and potential function we got here. Based on that, we can draw the, a stream function and potential function both. So what value we will have here? See, in short I am telling you, okay, in short I am telling you, if you go the plot, so plotting of phi and psi. So you know psi is the stream function, and for the stream function is nothing but the, it's a stream function is basically constant along a streamline. So streamline have a direction, and equipotential line we do not have any direction, already I have told you. So first you have to draw stream function psi. Okay, so now this is what x and this is what y. So we have velocity along x, that is v, but along y we do not have any velocity. Okay, so actually along x, what is the component u, and u is nothing but v. But what is the velocity component along y? That is v, and v is nothing but 0. That you know very well. Okay, now what is the psi? If you check y, it is nothing but magnitude wise it is vy. If you change the value of y, we'll have a different stream function. Means here what is the value of y, here what is the value of y on x axis. On x axis value of y is nothing but 0, because you are going to talk stream function, and stream function is nothing but it's a vy. It's a vy. Okay, it's a vy. Now my point is, if you talk about y is equal to 0, so what is the stream function? Stream function here is nothing but 0. Similarly, we can go for the, if you talk about the magnitude only, if you talk about the magnitude only, okay, so next y value is what? Y1. Now it becomes y1, and if it is becomes y1, y is equal to y1, here y is equal to 0, and y1 is nothing but just say 1. So what is the psi value? Will be psi 1, right? Psi 1. And what is the psi 1? Because y1 you have taken 1, so psi 1 is nothing but v. Similarly, you can take psi 2 2v, psi 3 3v, like that. Psi 4 4v. And if you want to draw the potential function, so what is the potential function? Just see, potential function is nothing but phi is equal to vx. Here also, if you are interested about the mod value, so it is nothing but mod of vx. Means if you are changing the value of x, will get a different value of phi, right? Now, and also, you know, stream function and potential function, equipotential function and stream function, both are orthogonal. Orthogonal means perpendicular. So if this is the stream function, I want to draw potential function phi, then it should be perpendicular. Means like this, just perpendicular. Something like that. So here this is what x is equal to x1, which is nothing but x is equal to 1, and this is what x is equal to 2, x is equal to 3, x is equal to 4. So this is nothing but what? This is nothing but phi 1. Obviously this will be the phi 0. Okay, and just like here, this is the psi. So this is what phi 2, this is what phi 3, this is what phi 4, and here obviously this is what phi. If you check x here, this is what x is equal to phi. So what is the phi value? It's a phi times of v. It's a 4 times of v. It's a 3 times of v. It's a 2 times of v. It's a v, like that. So if you check, stream function psi and phi both are perpendicular to each other, right? This is the plotting of the stream function and potential function. Hope you understood this. Similarly, coming to the uniform flow parallel to y-axis. If you talk about the parallel to y-axis, okay, uniform flow, parallel to y-axis, right? Parallel to y-axis. So if you talk about parallel to y-axis, so you can draw the pattern by your own only. Parallel to y-axis means what? You draw the coordinate system. This is the coordinate x and this is the coordinate y. So if you say parallel to y-axis means something like this. See, this is the flow which is parallel to y-axis. See, this is the flow parallel to y-axis, right? This is the flow which is parallel to y-axis. I can show you the resultant velocity here. It is also, just say v. Okay, this resultant velocity is nothing but v. If your axis is what, x and y, something like this, this is x and this is what, y. So along x-axis what is the component u, and along y what is the component v. See, if it is parallel to y-axis, and if you see parallel to y-axis resultant velocity is v, then what is the u? Parallel to x, u component will be 0, and parallel to y component, what is the small v? That is capital V, right? So this is the mean of it. Now the same thing you have to do for the parallel to y-axis also. What is the stream function? If you go to the
सर जी
stream
पीछे
function,
वाला कंप्लीट नहीं किया था सर जी,
okay,
स्क्रीनशॉट ले लेता हूँ.
done,
डन सर जी,
right?
डन डन.
Yeah, stream function, if you go, so it's very simple. Stream function, you can write u is equal to minus dou psi by dou y, and v is equal to dou psi by dou x. As here you can say u, that is horizontal component, which is 0, so you can keep this is nothing but 0, and y component, that is small v, is nothing but capital V. So I can say psi is nothing but v times x. V times x, that is psi, which is nothing but a stream function. Okay, this is the stream function, and similarly you can do for the potential function also. Similarly, you can do for the potential function. So what is the potential function? It's u is equal to dou phi by dou x, and v is equal to dou phi by dou y. U is nothing but 0 here, and v is nothing but capital V. So what is the phi? Phi is nothing but v times y, right? Phi is nothing but v times y. You have to integrate. This is the differentiation. You have to integrate, then you will get v times y. Okay, that you should know, no? All right. Now we'll go for the plotting. Plotting of stream function and potential function, right? So see here, what is the stream function? It's nothing but psi. What is the potential function? Nothing but phi. And if you want to check that plot, so you just combine all. You can draw here. This is what? Stream function and potential function, both equation you should aware. What is the psi? Check. Psi is nothing but v times x. V times x. Phi is nothing but v times y. So first what you have to draw? First you have to draw psi, because stream function have a direction. Okay, and that is a streamline basically. So check, this is x-axis and this is y-axis. So if various x-axis if you draw here x1, x2, x3, so obviously here x is what? X is 0, here x is 1, here x is 2, here x is 3. Similarly, you can say y is 0 here. This is y is equal to 1. This is y is equal to 2. This is y is equal to 3. And this is y is equal to 4. Right? Now, so first what you have to perform, you have to draw the stream function first. So where is the stream function? x value. A stream function is what dependent here on x. If you are making x is equal to 0, so this y axis will be psi 0, and x is equal to 1 means this is the psi 1. X is equal to 1 means this is the psi 1. What is the psi 1? You keep x is equal to 1, so psi 1 is nothing but v. Then another, this is what? Psi 2. What is the psi 2? X is equal to 2, so this becomes 2v. And here, this is the psi 3 means 3 times v. Right? Similarly here, if you check y1, so y1 means, the y1 means phi 1. What is the phi 1? Phi 1 is nothing but obviously v. Phi 2 is nothing but 2v. 3v, and this is what? Phi 4 is nothing but 4v. Sorry, here equipotential don't have any direction, so better you don't show arrow. Okay, arrow will have only for the stream function, because stream function will have a direction. So if somebody asks you, okay, can you draw equipotential line directly? No, you can say no, directly I cannot draw. First I will draw a streamline for that particular function. The stream function we have to draw, and stream function you have to represent by the streamlines, and then perpendicular to the streamline will have a equipotential line. So this is the plotting, okay, stream function and potential function. I hope this one is okay. Uniform flow, but it's a inclined by theta with x-axis. Okay, anything you can take. You can take inclination with y-axis also. It's your choice only. So now if I make a coordinate system x and y, this is x and y coordinate system, this is y, and this is what? X. So if I want to show the inclination theta for the inclined flow, so this is the inclined flow. Now see, this is the inclined flow, this is the inclined flow. Okay, but if you check the angle, so obviously this angle is nothing but theta everywhere from the horizontal, from the x-axis. So this is what? Inclined flow. Okay, this is what? Inclined flow. Now, so what is the resultant value of inclined flow? It's nothing but v. Now, so how to approach for phi and psi for this inclined flow? I must tell you, it's very simple. See, this is the v. If you check, resultant velocity for the inclined flow is nothing but v, and this is the, obviously this is the x-axis, sorry, this is what? X-axis, and this inclination from the x-axis is nothing but theta. This is what? X-axis, and this is what? Y-axis. Direction of x-axis, what is the component? U, and direction of y-axis, what is the component? V. Now if you check here, so obviously for the u, that is nothing but horizontal component, so this u will be what? You can say component of v along x, that is cos component v cos theta, and similarly in y direction v component will be what? V sin theta. There should not be any confusion. Okay, u and v both component will be there. U and v both component will be there, right? V sin theta, that is vertical component in direction of y, and component will be small v, and u, small u, is nothing but component in direction of x, and that will be the v cos theta. So if you calculate the value of psi and phi, so what will be the value of psi? You check it. I mean, you can say that if potential function or stream function depending on both x and y, then how to write that value? So what you will write? You will write psi is suppose the function of x and y now here. So what you have to write? You have to write d psi is equal to dou psi by dou x into dx plus dou psi by dou y into dy. So d psi is nothing but what? Dou psi by dou x. What is dou psi by dou x? It's nothing but v component dx minus u dy. What is the v here? Check. V is nothing but v sine theta minus u is nothing but, what is the u? U is nothing but v cos theta into dy. That is nothing but d psi, right? D psi. Again, if you want to calculate this value, which is nothing but, I can say I can take the common also. So d psi is nothing but v in bracket, I can write sin theta dx minus cos theta dy. Okay. Now what I can write? Psi is equal to, I can say it's a v as it is, sin, just simple integration. So sin theta, and here integration will be x, cos theta, here integration is what? Y. So ultimately what is the psi? That is a stream function, and psi you got nothing but, I can say vx sin theta. I must write vx sin theta, vx sin theta minus y cos theta. This is what psi, that is stream function, right? This is what is stream function for the inclined line. This is the stream function. How to get the potential function? So potential function is nothing but the same mathematical calculation you have to perform. It's a d phi, or you can say phi is the function of obviously x and y. So what is the d phi? D phi is nothing but dou phi by dou x dx plus dou phi by dou y into dy. What is dou phi by dou x? It is u plus dou phi by dou y is nothing but v dy. Nothing but d phi, right? Simple. Here you can say, what is the phi? You can say phi is nothing but ux plus vy. That is the phi now. Okay, ux plus vy. So I can say phi is nothing but ux plus vy. I will keep all the value. What is the u? Check it. What is the u? U is nothing but v cos theta. V cos theta x plus, what is the v? V is nothing but v sin theta y. So what is the phi? Basically phi is nothing but x cos theta plus y sin theta. X cos theta plus y sin theta. This is nothing but phi. Okay, this is nothing but phi for the inclined flow. Always remember, very short format I am just explaining you. In if you integrate, then again constant and all, everything will come, but don't care in that, because in competition you have to remember the final result. That will be very useful for you, and don't go for the full derivation. Techniques you have to learn. If I will go for the plotting, so how you can plot it? It's very simple. As you know, direction of the flow always will be represented by the stream lines. So if I say it is the inclined, if I say it's an inclined flow, so means all the streams lines will be inclined, all streamline will be inclined, and that will be the stream function. Okay, if I say these are the streamlines, because flow is what? Inclined flow. So you, if you want to show the flow direction, so always you have to show by the streamlines. So now this is the streamlines like this. These are the streamlines, and along the streamline, obviously our stream function psi will be constant. Just say this is the streamline 1, so here it is psi 1, this is psi 2, this is psi 3, this is psi 4, and this is what? Psi 5. If you want to calculate the value of psi 1, psi 2, psi 3, then how you will calculate? You should know this value. V will be constant, x sin theta minus y cos theta. If you are knowing the value of x and y, and it's very easy, nah? It's very easy. If you go for the coordinate system, this is what x here and this is what y here. So at any point, if you are talking about this, if one particular streamline you can take, suppose you are talking about this streamline, so here you should know this value. This is nothing but obviously x3, there will be some value, and this is what y3. This is what y3, so there also some value will be there. So x3 and y3 both are known. So here, what is the psi 3? Psi 3 is nothing but v in bracket. What is the psi 3? Check. Psi 3 is nothing but v x sin theta minus y cos theta, means x3 sin theta minus y3 cos theta. So that value you might be knowing. Anyway, so I mean, if you are interested to calculate psi 1, psi 2, psi 3, it's okay. Otherwise, if you are interested in pattern only, so definitely this will be the stream function pattern. Now, if I ask where is the potential functions, you have to say perpendicular to the stream function, or perpendicular to the streamline. So what is the perpendicular? Perpendicular means something like this. See, this is the potential function perpendicular to the stream function, right? Like this. So obviously here this, you can say this is phi 1, this is phi 2, phi 3, phi 4, phi 5, something like this. So this is nothing but the plotting of psi and phi. Okay, plotting of psi and phi. This is for what? This is for the incline to the horizontal axis. Uniform flow inclined to the horizontal axis. Okay, anywhere you can show the direction. This is this direction, you can, this is theta. Anywhere you can show the flow is what? Inclined with theta angle. Okay, so this will be the flow pattern with respect to psi and phi. I hope the value magnitude of phi you understood. This is the magnitude of phi. Again, if you are interested to get any value like phi 1, you are interested, so it will be v in bracket x1 cos theta plus y1 sin theta. If you put in coordinate system, so for x1, or you just suppose you are interested about phi, so phi means here, see, if you are interested, suppose for this, so any point you can take for this, obviously it will be constant, right? So suppose for this, if you are interested, then you have to draw it on x-axis and obviously y-axis also, and everywhere if you check that x phi and y phi value, and you keep in the formula is this one. If you are interested phi, then it is nothing but vx phi cos theta minus y phi sin theta. Simple. Similarly, and you know that you don't think this phi, what is the value you are getting? This phi value will be constant along the line. Doesn't matter, anywhere you can calculate, this magnitude will be constant, right? Similarly, phi 2, if you calculate, then this phi 2 will be constant everywhere, right? Phi 3 will be constant, phi 4 will be constant.
सर पहले वाले
Correct. So potential function will be constant along the equipotential line. Basically, these blue lines are equipotential lines, and along the equipotential line, your phi 1 will be constant. For another equipotential line, phi 2 will be constant, then phi 3. So, but stream function and potential function both are perpendicular. So in this way, you can show the pattern. All right, it's very helpful for you. Examination questions are asking something like this, then you have to answer for that. So here we'll talk about the source flow. Okay, source flow. Basically, from where that source flow comes. So basically, radial flow. Okay, this radial flow. Radial flow, basically two types of radial flow we'll have. That is source flow and
Sink.
sink flow. Always remember, radial flow means along the radial direction. This flow will be along the radial direction. There is no circulation, there is no vortex, nothing. Along the radius, along the radial distance, you can say, better word, along the radial distance. So this flow basically, both source and sink, magnitude wise it is same, only direction will be just opposite to each other. Okay, opposite to each other, that is direction, but magnitude wise or strength wise both are same. There should not be any doubt. And if I say source flow, so it by the word only it indicates that source flow means flow away, flow away, flow away from from source. Okay, and sink flow, again by the word only you can say sink flow means it is sinking the flow. So it's just opposite to the flow away. Flow away means from the source it is going away, it is going far away, means it's just coming out. But if I say flow, that is sink flow, then it means flow in. Flow in towards sink. Okay, towards sink. So anyone you can take positive and another will be automatically negative. Anyone you can take positive, generally source will take positive. So how to understand? Suppose this is the source, and this source is what I can show you in 3D. I will try my level best, but definitely it is not possible. But yes, suppose this is the suppose something like this. This is the, you can say, this is the one pot here, and from the pot with very high pressure, this pot is what filled with very high pressure. Okay, fluid inside the pot we have with very high pressure, and once you open this knob, then flow will comes like this. Flow will comes like this. Okay, flow will comes like this. So matter is, if this is what source, so if flow is what something like this, then it is called as a source. Okay, it is called as a source. Flow is coming out from the source. Something like this. Okay, so if you check here, we can consider this point here, this hole is nothing but, you can say, this is what source. What is this? This is nothing but source. So in case of the source, the flow will be coming out. Okay, the flow will be coming out. Will be coming out from the point, and that point is nothing but source. So this was the flow which is coming out from the source, hence it is called a source flow. So this is all about source flow. But what about sink flow? Sink flow, if you check, this is the one vessel here. Okay, this is the one vessel, and if you see, and something like this it is. Okay, this is the one vessel. Huh? Inside this we have a fluid, obviously, and that fluid is what coming down through this hole. That fluid is what coming down. Here we have a fluid. Fluid is what available here. Fluid is what available here, something like this. So fluid is what coming out, something like this. This fluid is what coming, something like this. At your home also sink is there, right? Basin is there, sink is there. Nah? So actually, if you see this diagram, so how it looks like, suppose this is the one point. Obviously, this is one hole, and all the flow, if you want to show, then the flow will be like this, coming towards the points. So in this was coming out, and this is coming in. Flow will be coming in towards the points, and this point will be the sink point, basically. Something like this. See, so coming in, flow is what coming in, right? So this is called sink flow. Sink. So strength wise, whatever the strength of the flow, definitely we'll discuss it. So strength of source and strength of sink, magnitude wise it is same, but direction wise it is just opposite. Okay, if I say this strength of source, okay, if I say strength of source, which is nothing but discharge per unit depth, discharge per unit depth, if I say per unit depth, what is the strength of source? That is discharge per unit depth. So I can consider discharge is nothing but Q. I can say discharge is nothing but Q, and obviously if I per unit depth, if I will check, okay, then per unit depth, then obviously it will be small q, it will be small q, okay, it will be small q. So I can say discharge per unit depth, it is denoted by now q. So strength of source is nothing but q. So for the source, this strength of source is what? Plus q. And the same thing will have for the sink also, but also it will be discharge per unit depth, but flow will be inward, hence this strength of source is nothing but minus q. Otherwise, magnitude wise both are same. There is no difference at all. There is no difference at all. So today, like I have discussed here, source and sink. Mathematical model next class will define, and obviously it is very well known now, because this is a radial flow. This is radial flow. Source and sink both are radial flow. So as you know, for the polar coordinate system I had explained, if you remember, this is what radius r, and this is what theta. So along the radial direction, right, along the radial direction will have a radial velocity, and along the tangential theta will have v theta, that is tangential velocity, and along radius is nothing but vr, and this is resultant velocity, which is nothing but v. Okay, so basically this v velocity, v resultant velocity, will have a two component vr, that is radial, you can say I plus v theta j. In this way also you can write. So my point is, if we are writing radial and tangential both, so for the source and sink, because it is the only radial component, so for the source and sink only vr will exist here. Okay, only vr will exist here. For radial velocity only radial component will exist, means that will not be zero. But what about tangential component v theta? It must be zero, because source and sink means it's a radial flow. So whenever you will talk about the source, so only radial velocity you have to talk, that will be zero. But what about tangential? It will be zero. But radial will not be zero, because it's a radial flow. If radial flow is there, then obviously radial velocity will not be zero, and tangential velocity will be zero in case of source. As well as the same thing happened to the sink also. So because it's a radial flow, so radial velocity will not zero, but tangential velocity will be zero. So mathematical model will derive, will complete in next class. Now onward,